All right, the timer has started. Countdown begin. All right, this talk is bash scripting, do this, not that. I'm really, really surprised to be in this room and to be standing in front of you, all of you. Thank you for coming. My name is Ryan Manley, @rmanley on Twitter, rmanley on GitHub, ryan.manley@gmail.com. I work for a high school district in northern suburbs of Chicago, Glenbrook High School District in Glenview and Northbrook, for those of you who may be familiar with the area. When I started working there in 2009, the district had about 1,700 dual boot Macs that they were managing with the Casper suite. Now, the students are 3 years into a one-to-one program, and Monkey Report PHP tells me I have 776 Macs. In the last few weeks, I have gained new responsibilities, and I am happy to announce that last week I successfully deployed 2 applications to our 600 or so Windows computers using Microsoft Deployment Toolkit and SCCM. Let me tell you something. I hate wizards. I hate wizards so much. Give me a nice, quick CLI any day. And like many of you, I have been using computers for a long time. This was my first computer, a Commodore 64. Yeah? I say my computer, but I really mean the family computer. I was 2. I played games on it. I did not learn to start programming on it. In fact, programming or scripting didn't interest me until I learned about batch files sometimes around Windows 3.1. I spent long hours playing with batch files. I even got it into my head once that I would create a batch file virus that would infect autoexec.bat and replicate itself. I ended up deleting the entire contents of a hard drive. Do you remember what an old PC did when you turned it on and it didn't have an operating system? Blinking cursor. That's it. And this is when I turned off the computer and backed away slowly. I told my mom what really happened many years later, though I'm sure she knew that I was the reason she was reinstalling MS-DOS and Windows 3.1 from floppy disk that night. So I started bash scripting in 1999 when I first started to use Linux. It was my scripting language of choice when I made the transition to OS X after falling in love with the 12-inch PowerBook. That was a beautiful computer. So why are we here? Why am I giving this talk? Remember this story from a few months ago? Yes? No? Maybe? I think a lot of you are here because for at least a little while, despite the somewhat obvious in hindsight problems with the story, we all thought, yeah, I can see that. We've all been there. Many have written a script that blew up in some crazy way and started spewing files all over the place, filling up hard drives. I know I, not including the virus batch file I mentioned previously, have accidentally deleted things I didn't want to. I hope that some of the things I talk about today will help you make less of these mistakes. So, what am I going to talk about? PEMDAS, parentheses, exponents, multiplication. No, not really. But I will talk about the order of expansions. Word splitting, quotes, even, more, quotes. Tom Bridge shared this image on Slack when he got it from a tweet by Nick Arnott a few months ago. Yeah, it's funny because it's true. Bash scripting can seem like this a lot of the time. But if you follow the following suggestions, you should be able to avoid this trap. I will address quoting throughout the entirety of this presentation, calling it out explicitly many times when the man page has something to say about a particular feature. In general, though, you should quote every expansion until you learn where you don't need to. If you are new to bash scripting, after this talk, go through the bash guide. And if you have a thick skin, go on to the Freenode Bash IRC channel, although they'll probably yell at you a lot. And then, like I said, quote every expansion. If you are a wizened veteran of Bash, do yourself a favor and go through the Bash guide. I guarantee you will learn something. Then go through Bash pitfalls. You may have a few eureka moments in there. With that said, let's get going. First up is order of expansions. What is an expansion? In Bash on OS X, there are 8 kinds of expansion. The man page says 7, but then later on says there is an 8th called process substitution that is supported on some systems. OS X is that type of system. So the 8 kinds of expansion in OS X are brace expansion, tilde expansion, parameter and variable expansion, command substitution, arithmetic expansion, word splitting, pathname expansion, and that weird one, process substitution. Like PEMDAS in mathematics, expansion on the command line happens in a certain order. Most of the time, this will not trip you up. Usually what trips you up in expansions is not the order of operations or execution, but the quoting. The expansion order, brace expansion, tilde expansion, and a doozy. Parameter, variable, arithmetic expansion, command and process substitution, word splitting, and pathname expansion. The third expansion contains a lot, but happens in left to right order simultaneously, just like in math with multiplication and division or addition and subtraction. To reiterate, parameter, variable, and arithmetic expansions and command and process substitutions all happen at the same time from left to right. I'm going to touch on each one of these for two reasons. One, I think quoting is mentioned in every single section of the man page for these. Two, there are some good but infrequently used features in here. People end up reinventing the wheel or using external programs for things that could have been done internally with Bash alone. First up, brace expansion. Brace expansion is really handy in an interactive session. That is where I use it most often. This tip blew some people's minds on the Mac Enterprise or Jamf mailing list a few years ago. It will definitely save you a lot of typing. Here we have a directory with a single file. And we want to create a backup of it because for some reason it is not in version control. So normally we would have to type cp file.plist, file.plist.back. But no, we are all awesome Bash users and are above such nonsense. We will use brace expansion. That is this, yeah. So what is happening here is file.plist is acting like a preamble to the expansion. We aren't adding anything to that preamble for the first item because there is nothing in front of the comma. Then the preamble file.plist with the .back get together and become the second item we need for CP to work properly. The echo at the bottom might clarify what is happening a little better. We have echo preamble, comma, with nothing. So we just get pre, post, pre-ex post. We're doing the same thing up here. We expand out file.plist to itself, and then file.plist.back, and we get a nice copy. People went nuts for this. I don't know. Another handy feature, or another handy use for brace expansion is creating a big directory structure. For sysadmins, this is probably the coolest thing to do with brace expansion in a script. Say you get home next week and you're super excited to finally try Monkey after hearing everybody talk about it at PSU. The demonstration setup wiki page would have you create a bunch of directories by running makedir 4 times. But I say nay, this shall not be. Here, I'm running makedir and passing it the P option because the monkey repo directory does not exist yet. Then we're using brace expansion to create the rest of the subdirectories I need. As you can see, when I ls the glob, monkey repo contains catalogs, manifest, packages, packages, info. You can continue on and make that super, super complex if you want. Quoting quotes. Quoting in Bash is really important, as mentioned many times already. Here's the first of my quoting quotes direct from the man page. It has this to say on brace expansion. A correctly formed brace expansion must contain an unquoted opening and closing braces and at least one unquoted comma or a valid sequence expression. Does anyone know why we can't quote our brace expansions? What would I get if I typed this into the command prompt? I heard it, yeah. I get a subdirectory inside monkey repo directory that is literally called brace catalogs, comma, manifest, comma, packages, comma, package info. That is pretty obviously not what we want. So that was brace expansion, the first kind of expansion, and the first thing to be expanded in the order of operations. Second in the expansion order, we have tilde expansion. What are we talking about here? Doesn't tilde just mean home? No. It means so much more. I can't do a good Merlin Mann impression, but turns out Bash is actually looking for other stuff around the tilde. First and foremost, tilde expansion is looking for a login name. When bash doesn't find a login name, it is replacing the tilde with the parameter home. That's $HOME. If that parameter is not set for some reason, then home for the user executing the shell is used. But if we do supply a username, then we can use it to find out what other users' home directories are. Where does the local admin live? Nothing too surprising, just in the user's directory like everyone else. But root's in var. Somewhat less useful is that you can use tilde expansion for getting the values of PWD and old PWD. Here you can see that when I wrote this, I was sitting in my brace expansion test directory, and the last directory I was in was the fake monkey reto directory from the previous little demo. What are the quoting quotes for tilde expansion? Short answer, tilde expansion should be unquoted in order to expand properly. Just as with all potential file name expansions, though, you need to be careful of spaces in the resulting paths. Let's go to the man page for details and another installment of quoting quotes. If word begins with an unquoted tilde character, all of the characters preceding the first unquoted slash are considered a tilde prefix. If none of the characters are quoted, the characters are treated as a possible login name. If the login name is invalid or the tilde expansion fails, the word remains unchanged. Here are two examples where I attempt to expand the tilde, adding the subdirectory test, and I also need to deal with a file name that happens to have spaces in it. If I move the quotes a bit, as in example 2, I prevent the expansion of the tilde, and I do not get the full path that I may need later. These examples illustrate the fact that one of the things tilde expansion is looking for is an unquoted slash. The top one does not find an unquoted slash, so the word is left unchanged. The tilde word, it just gets kicked down. The top one, if we put the quotation mark on the other side of the slash, as in the bottom example, the expansion works properly. Users, Ryan, then the rest of the path. Remember, the text before the first unquoted slash is what will be treated as a potential login name. You can see this again in this final example. Instead of just using tilde as a shortcut to our own home directory, we let the tilde prefix find root's home. We'll address better ways to deal with file names that may have spaces or weird characters later on. Brace expansion and tilde expansion were covered briefly. The next thing to be expanded is parameter, variable, arithmetic expansions, and command and process substitutions. Parameter expansion is a huge topic, so I'm just going to touch on two cool features. In bash, a parameter is an entity that stores values. A variable is simply a parameter with a name. I'll address both of them with this. In my opinion, in a script, all variables should always have braces around them. This is the first element of style I will impress upon you today. When you enclose variables in curly braces, it serves two purposes. One, it sets them apart. It is much easier to pick out variables when skimming a script if the braces are present. And two, it gives you access to all sorts of cool parameter expansion features. I'm only going to highlight two expansions here because I think they could be used to get rid of a lot of checking variables with -z, and also because some Python programmers in the crowd might be excited to learn that this can be done in bash. Here we have an unset variable foo. Boop. It echoes out nothing. In the second command, what I am doing is assigning a default value. This means that if foo is unset or null, the expansion of bar gets assigned to foo, and then the result of foo is substituted. To walk through this slowly, foo is unset, but we want to echo something. So the string bar is assigned to the variable foo, then the result of that substitution is echoed out. Now, as you can see, at the end, the assignment persists. The variable foo has the string value bar. This is incredibly powerful. You don't have to check if something is a zero-length string with -z all the time. Now, for something slightly different. Again, we have an unset variable foo. This time, though, we are simply using the default value baz. When expanded, baz is used if foo is unset or null, but baz is not assigned to the variable foo. Let's step through this one as well. Foo is unset. It doesn't exist. Baz is a variable with the string nope. Once again, I want to echo something. Foo if it is there, otherwise I'll take the message in BAS, but I don't want to mess with foo. I want foo to remain unset and unassigned and BAS to hold the message. When I use this expansion with the minus instead of the equal sign, this is the behavior that I get. What can you do with this? I've used it in the past for extension attributes in Casper and other similar reporting type situations where instead of getting back nothing, I want to display an alternate message. Arithmetic expansion simply lets you do math. Here's a counter using arithmetic expansion. There are a lot of strange issues when doing math in Bash. I have almost no experience with it, honestly. But I do know it has weird behavior, like sometimes when you're evaluating numbers with leading zeros, Bash treats them as octal. So that's cool. Might do this, not that for math in Bash. Move along. Command substitution is next. Command substitution allows you to replace the command name with the output of that command. The general form is simply to use a $ and a set of parentheses to enclose the command you want to replace, as shown here. What Bash is doing is executing the command, who am I, in a subshell, and taking the output of that command and substituting it on the line. Thus, the assignment here becomes equivalent to my username equals Ryan. That is essentially how command substitution works. But I have a few more words about command substitution. Everybody, pay attention. This is very important. Stop using back quotes. But why, Ryan? Why? Why should I stop using back quotes? When you do a command substitution, there are two forms. And I was originally going to address it and say, don't ever do this. But back here, you can use, instead of $paren and paren there, you can use the grave character, the tilde, shift tilde. That's a back quote. Back quote, backtick, grave. So stop using them. Why should you stop using them? The first reason, a lot of the time they are really hard to read. Look at this and keep in mind this is on a giant screen with syntax highlighting and an OK typeface. We've got some single quotes in there and some double quotes in there. It's pretty messy. Not convinced? Imagine getting this email with a bunch of other text around it and a colleague asking you for help troubleshooting. You can look through the archives for the Mac Enterprise mailing list or the old Jam female list and see quotes and back quotes all munged together. And it can be really difficult to discern what is happening without copying and pasting the text onto something else. I really like that the suggested reply is, yes, it is. This is some text. Yes, it is. Maybe that isn't good enough for you. Maybe you think I just need glasses or better syntax highlighting rules in my .vim folder. Well, how about another reason not to use back quotes? Escaping nested back quotes is crazy town. It's insane. And it's really hard to come up with examples of this because there are better ways to do these kinds of things with loops. Before we get started, let's see what the man page had to say. Emphasis added. The first back quote, not preceded by a backslash, terminates the command substitution. Yeah, gross. Second one is a lot nicer. All characters between the parentheses make up the command. That seems really nice. I like that. The last one, escape inner back quotes with backslashes. So what does this mean? Basically, we are going to have to escape some stuff if we nest back quotes. To illustrate this, let's say I have a directory with some files. Maybe these are package info files for Monkey. And I want to see all the package info files that have the version number for the computer I'm currently using in them. I don't care where or why it is in the package info, just if it is there. These aren't real package infos. These are just files that have one line in them. File 1 says 10.11.5, so we'll be looking for this one. File 2 says 10.11.4. File 3 also says 10.11.5. We won't want this one as well. And file 4 is empty. Now I want to take all the files that have the version number for the machine I'm using right now and do something with them. Let's just throw it in a tarball. I'll break down this command. First, I'm getting the product version with swvers. Then I'm going to substitute the result of that command and use it with grep. This grep uses -f so that the dots in 10.11.5 are not interpreted as regex. -L to give me just the file names with the items that match, and -R because if this was a real monkey repo, there would probably be a bunch of subdirectories. Finally, the dot at the end is just telling grep to search the current directory. After grep has gotten me the two files I know contain 10.11.5, we will tar them up into a tarball called foo.tar.gz. The eagle-eyed among you are going to start thinking, he didn't quote any of those expansions, and you're right. But this is a contrived example, and I wouldn't rely on word splitting to accomplish this task anyway. So, as a quick aside, let's see why I didn't or can't quote every expansion when using tar in this example. If I set X, and I run the grep without quotes around the command substitution of swvers, everything works fine. swvers spits out the product version. Boop. Grep searches for that string, and the two files I expect are found, file 1 and file 2. If I quote the expansion of swvers, everything still works as it should. Similarly, if I just quote swvers after adding the tar command, the example still works. But now we have a problem. The last line of the command substitution section in the man page states, if the substitution appears within double quotes, word splitting and pathname expansion are not performed on the results. Grep is giving me one file name, then a new line, then another file name. Tar doesn't work like that. Tar wants all the files at once. And right now, tar is looking for a file that's literally called ./file01 text new line ./file03.text. In this example, I'm actually relying on word splitting to remove that new line and pass the right tokens to tar. Scary. Back to our regularly scheduled program. Before that rabbit hole, I was showing you why nested backquotes are evil. We left off with tarring up some files that match the grep for the current product version. Fine, good, that works. But now what if we were using backquotes? That isn't that bad. Backquotes around the grep, boom, boom, and then escape the backquotes from the nested substitution, here and here. Hold on. That's not enough. We have to go deeper. Let's add one more level. Peter Pukowinski gives an example of this in his 2014 Mac Admin at Penn State talk entitled Shell Building Blocks. 10 minutes into his presentation, Peter shows that when escaping nested backquotes, you end up having to escape your escapes to preserve them. So in the second level of nesting, 3 backslashes are required. You know what's coming next. I used an Inception meme. We have to go deeper. Here's a screenshot from James Panicelli's talk, GNU Bash, an Introduction to Advanced Usage at OSCON in 2014. There are 5 levels of nesting there, and 15 backslashes are needed. It's a little nuts. James admits moments after showing this on the screen that he didn't even know how many backslashes he needed. He just kept adding them until it worked. But maybe, just maybe, you are still not convinced that you should stop using backquotes. It's not that big deal, right? I haven't said that the examples were contrived. OK, fine. How about this? Reason number 3 not to use backquotes anymore. Some guy says that $paren is cleaner.
The backquote, which is the command substitution, which I would have done differently these days, and in fact I think the newer shells have a $paren something, which is a much cleaner way to do it. excuse me, didn't think of that at the time.
See that citation? Bourne Stephen R. That is the Stephen Bourne, the author of SH. In a keynote he gave at BSDCan last year. Let's give it another listen.
The
I just love it.
Which is the command substitution, which I would have done differently these days, and in fact I think the newer shells have a $paren something, which is a much cleaner way to do it. excuse me, didn't think of that at the time.
Stop using backquotes. Just stop. Process substitution. We've already covered most of the expansions in the order in which they are processed. I showed you how to create deep directory structures with brace expansions. that the tilde means more than just your home folder. I also covered some cool tricks with parameters. Arithmetic expansion can just go sit in a corner and feel bad about itself. And hopefully I convinced you to no longer use archaic methods to create command substitutions. Believe it or not, we are still only on the third item in the expansion order. Recall that parameters, variables, arithmetic expansions, and command and process substitutions all happen on the same step. We are finally at process substitution. Process substitution is a bash feature. You can't use it if you are putting bin.sh on the shebang line at the top of your scripts. I was reminded of this just a few months ago when someone emailed me about a script that I posted to Jamf Nation or the mailing list in 2012. In the message, I didn't put a shebang line, and this person was getting errors. We emailed back and forth, and I gave him a little tutorial, and I edited the post so that there's a shebang, and it is bin bash. Process substitutions are incredibly powerful for two reasons. One, it creates a named pipe, a.k.a. a FIFO, for you. Then that named pipe is passed as an argument to the command. In short, it removes the need for you to create temporary files. I'm not going to cover named pipes here, but know that they are cool, and you should play with them. The second reason to use process substitution is that you can use it instead of piping into a loop. Doing this will preserve any variables you modify inside the loop. In this example, I'm piping the plist I find in the Anaconda directory into a while loop. So here we set I to 0, we find some plist, we pipe them into a while loop, and for each line, we're going to increment I, and then we're going to echo the plist at the end. For each line, I'm using that math stuff to increment a counter. The problem is, because I'm using a pipeline, the loop is running in a subshell, and the variable is lost when the subshell exits. If you run this script, it will always echo out that 0 plists were found. So, how do we do this with process substitution? We combine the redirection and the process substitution operators at the end of the loop. If you always create while loops like this, when using find, etc., and never pipe things into them, then you will never have to worry about the unexpected loss of variables in those subshells. Using finds print 0 and setting reads delimiter to null also makes this the safest way to use find to get file names. This way, file names could even contain a new line, and since read is looking for null characters as its delimiter, those new lines will be kept. And incidentally, if you were curious, the answer is 35. There are 35 plists in my Anaconda directory. Word splitting can be really quite simple if you don't modify IFS. Word splitting is typically why we are always faffing about with quotes in bash. We need to protect things like file names, which may contain spaces, with double quotes. But at the same time, we need to be able to iterate over items, etc. Ideally, you should never put yourself in a situation like I did with the grep-tatar example earlier, where you are relying on word splitting to sanitize your input. What is IFS? If word splitting relies on IFS to do its work, what the heck is it? IFS stands for Input or Internal Field Separator. And by default, it is set to the tab and new line characters in that order. So what? What does it do? IFS describes the characters, the rules, if you will, that word splitting will use to break apart the items in a command. There is a helper script on the Woolidge wiki that can help illustrate this. I've had it in my user level bin directory for years, and I forgot where it came from until I was putting together these slides. If you save this little guy somewhere in your path, you can use it to help you understand word splitting by experimentation. You can also toss some complex thing you are trying to whip up at it to see why it is breaking. I'm getting these examples right from the wiki because they do a great job of illustrating a problem you will run into when you start quoting every expansion. In the first example, var is unquoted, and after it's expanded, word splitting breaks it up and we get 4 arguments. So we have var is assigned, this is a variable, and then we run the arg script from before on var, and we get this is a variable. Word splitting has broken it up on these spaces. In the second example, we quote the variable var, maybe because it might be a file name with spaces, and we get one word because we protected it. The solution to get the behavior we want in nearly all cases, especially when dealing with file names that could have all kinds of wacky stuff in them, is to use globbing and arrays. In another exciting episode of Quoting Quotes, we learned that word splitting happens a lot. The shell scans the results of parameter expansion, command substitution, and arithmetic expansion that did not occur within double quotes for word splitting. Got to quote a lot of things. IFS can be manipulated. You can make it something other than the default for doing fancy stuff like word splitting on slashes and path names, etc. But if you do it, the safest way to do it is like this. While IFS equals something like slash or semicolon or whatever, read, and then do your work. This only changes it for that loop and doesn't change it for anything else in the environment. Then you don't have to worry about the trivialities of IFS not being default or doing something dumb like assigning IFS to old IFS. Finally, we come to the last expansion. Pathname expansion is also called globbing. You must remember that this happens after all the other expansions, because if you end up with unquoted wildcard characters at this point, you may get results you do not expect. Quote every expansion, and you usually won't have to worry about that. Today, I will highlight 3 expansion options that can help you ensure you get the results you want. Pathname expansion is one of my favorite things in bash scripting. Here, I've created an array called D-array with everything in my home folder that starts with a capital D. Also, here's another little freebie tip. You can use declare P to print out the contents, the values, and the attributes of your arrays. Simple. Cool option time. First up, extended glob. Enabling extended globbing gives you some regex pattern matching features to your globs. The feature that I most often use is everything except. Here's what that pattern looks like generally. You do exclamation point, paren, pattern list. This matches anything except one of the given patterns. What can we do with this? Here I am sitting in the users directory. I've got guest, shared, ladmin, and Ryan users directories. How do I use a glob to get everyone except shared and ladmin? 1, I enable extended globbing. 2, I use the pattern matching to match everything except shared or admin, ladmin. Easy. You can replace echo with rm-f, and you can have a really, really fast way to have a bad day or a good day, depending on your perspective. The next 2 options to try to protect you from unintended consequences of globbing, but they go about it in different ways. When you set fail glob in your interactive environment or in your scripts, and the glob does not match anything, you will get an error. This can be good from the fail early, fail often philosophy, but sometimes you don't care if a glob fails. It should probably be used in any script that you want to make really, really rock solid. Has anyone heard of the so-called unofficial bash strict mode, or sometimes called safe script mode? Yes? Okay. If you want to write some amazing scripts that account for all kinds of errors and learn a lot, these are some of the settings you can enable to do just that. If you set E, U, F, and pipe fail, that's typically what's recommended. Setting E causes the script to immediately exit if an error is encountered in a simple command. Setting U tells bash that if an unset variable is used, That is an error. Pipe fail causes pipelines to return failure if any command in the pipeline fails. When E is also on, this causes the script to exit. I skipped setF. setF disables pathname expansion. Since we are in the globbing portion of my talk, this is probably not what we want here. So if we want to make really robust scripts, but we also want to take advantage of globbing, this is how we can do that. We set EU and pipe fail, but then we turn on the option for fail glob. We don't use the F because that wouldn't let us do any globbing at all. This is what fail glob looks like on the command line when it is enabled. Here I'm trying to populate an array with Python files, but there are no Python files in this directory. So I get an error. Boop, no match. What happens when no Python files are in the directory, but I don't have fail glob on? I'll cover that next with null glob. Null glob should be set when you are using globbing to build an array. What does it do? Null glob removes the word when no matches are found. What does this mean? Here I'm creating an array called pyfiles again. And I want it to include every file in the current directory that ends in .py. In this example, fail glob and null glob are both off. So what's happened? I do the globbing, I assign something to the array, I get no errors. But if I look inside my array, I have this thing right here, asterisk.py. There are no Python files in this directory, but I still have that value in there. I wanted Python files, but if there aren't any, that's fine. I certainly don't want my array to include an item with the name asterisk.py. Setting null glob can fix this for us. First, let's clean out the array. Then, turn on null glob. Finally, let's populate the array again. Now, when inspected, the array is empty because there are no Python files in this directory. That means later on, when I start doing the work of my script, I just won't have anything to iterate over for this array. It is a lot better than trying to do something with a non-existent file called star.py. What are the downsides? Why not just have null glob set all the time? There are cases when no word on the command line or in a script can yield much worse results than a non-existent word. Here I am still in the same directory as when I finished up the previous example. There are no Python files in here, and null glob is still turned on. What happens if I ls star.py? I get everything. Why? Null glob has removed the word star.py because it didn't match anything. The command is interpreted by the shell here as just ls, nothing else. Moral of the story, set null glob in your scripts when you are going to build an array of files, but otherwise leave it off. Another time this will really bite you in the butt is if you're doing grep. Because if that last item disappears on a grep, grep thinks you're grepping standard in and just sits there. Well, that was the expansions, all in the proper order that they occur. Understanding this order is crucial to knowing when and how to quote or escape items, and to managing the impact of each level of expansion. To quickly review, I showed you how to use brace expansion to create files or directories. I showed you that tilde expansion isn't just about you. In parameter expansion, there are some neat tricks for working with default values, and I argued that all variables should have curly braces around them. I spoke about word splitting and IFS, and finally Pathname expansion, also known as globbing, and some things you can use to build more robust scripts there. Let's talk a bit about style. One of my biggest style gripes is uniformity. If, because I know nobody in here does this, if you copy and paste from a bunch of different websites, at least make things consistent. Don't do this. If I'm going through your script and I see you as both convention A if true, semicolon then, and if true then on a different line. A, I think you copied and pasted all your code from Stack Overflow. And B, it makes my head hurt. I don't care which one you use. I prefer the top one. Some people like the bottom one. Pick one. Stick with it. If you copy and paste code from elsewhere and it is different, change your code to match the rest of what you've already got. Test and the compound double bracket command. So much. You should be using 2 brackets because it has a lot more features than the single bracket. But either way, pick one and go with it. There are technical reasons why you might want to use the single bracket version, but I don't know how many people in this room are writing a shell script on OS X that they hope will also run on Linux or BSD or whatever. You should be using the double brackets. You'll learn. Asking software the right questions. The last thing I'm going to talk about today is asking software the right questions. What do I mean by this? Read the man pages and help for the commands and tools that you use. Very often, commands are mashed together in super long pipelines when simply using a specific option or a different tool was the correct way to go. Biggest offender, grep followed by awk or sed in a pipeline. I can't think of any reason to ever do this. Awk and sed both include very simple search syntax if all you want is to match one string. Very simple. In fact, if you learn enough awk, there's probably never a reason to use grep, sed, tr, or cut together in the same pipeline. If you want to learn more about awk or sed, I highly recommend 2 ebooks that were born out of an article series by Peter Crummins. The links here go directly to the ebook pages, but there are also free articles that led up to each book's creation. For $16, you will up your awk and sed game tremendously. Next biggest offender. PS grep, grep v grep. I hate this so much. Solaris 7 debuted with the pgrep tool in 1993. NetBSD got it in 2002. Linux got it in the early 2000s. I don't remember exactly when, but I know that I initially learned to look at process lists with grep v grep, but then I didn't have to do that anymore very soon after. Apple, in its benevolence, finally gave us pgrep in Mountain Lion. Pgrep by itself will just spit out the process ID for whatever match it finds. In the case of Chrome, it spits out a lot of process IDs because Chrome. pgrep also has a lot of options to do things like show the full argument list or to ignore case, as shown here with the -i. This is something I don't see too often anymore, but definitely happened a lot in 2009 or 2010. DSCL read something, grep for a specific value. You don't have to do that. You can ask DSCL for the key you want directly. There's no need to do any sort of text processing on it. This pattern is repeated in a few different tools. SWVers is another example, though I think that this one was born of a time when there were no options for SWVers. I don't remember for sure, but that would excuse it somewhat. Nowadays, though, just ask for what you want. There's no reason to do all of SWVers, search out for product version, and print to. Just tell SWVers you want the product version. This one isn't a gripe. I'm going to show you that there's help available to you. Have you ever tried to look at a man page only to be taken to the bash built-in section because you didn't realize, you didn't realize that command was a part of bash? Bash actually has a help command you can use for these instead of slogging or searching through that built-in's man page. A surprising number of people do not know that this is available. It's pretty handy. Now I'm going to show you something amazing. You don't always have to check the exit code of the previous command to see if it was successful. The command command bracket bracket is its own thing, and if is its own thing. Now that you know about the help command, let's see what it has to say about if. Huh. That says if commands, not if bracket. You don't always have to run a command and then check the error code with an if bracket bracket to see if it's 0. Just run the thing. Here I'm sitting in a directory with those files from before, the ones with the version numbers in them. File 1 had 10.11.5 and file 2 has 10.11.4. If I just want to grep for a match, I can just run grep in quiet mode so nothing gets dumped on standard error and check it. There's no need to do the grep and then see if $? is 0. Again, use the options, check the help. Grep can count with C. A lot of people don't know that. Every once in a while, I see grep pipe to WC. Grep can do the counting on its own. I guess what I'm saying is RTFM. I cover a lot of ground, and I hope you have learned something that you can use to help you make better scripts. I noted all the expansions in their proper order. I yelled at you about backquotes, and then ranted about style and learning more about the tools you use for a bit. Does anyone have any questions? Everyone's asleep. Everyone's like, oh my God, he read a lot of stuff. Oh my God, this is really early. Don't worry, I'm thinking that one too. Block?
Not on? There we go.
There we go.
What is your favorite code editor with syntax?
Vim. Absolutely Vim.
Which one? Which one do you use? What do you like?
No, literally Vim. Boom, right there, right on my dock. Yeah, because I like to drag things into it. What else? Incidentally, for Vim, if you want to learn Vim, Emacs, I don't care. They can be really helpful. If you learn a lot about your editor, you can do a lot of cool things. If you want to learn about Vim specifically, there was a set of podcasts called vimcast.org that can teach you how to do some magical stuff with Vim. Changing multiple lines, editing things in the middle of things, doing all sorts of weird formatting, making word art. It's crazy. All this stuff has applicable things to coding.
I have a short follow-up question.
Yeah.
Do you have a place or repository where you keep code snippets you find or write? Do you have a collection?
I do. I was using Codebox for a long time, but then I bought Dash. Mostly because I wanted fast access to Python documentation. So I've started storing code snippets in Dash as well. But Dash is a paid program. It has some weird naggy stuff it does if you don't buy it. But it's worth it. It's pretty cool. You can have all sorts of commands and shortcuts pre-downloaded for Bash, Python, grep, man pages, YAML. What else is in there? All kinds of things. What else do we got? Nothing? Oh, there we go.
Tabs versus spaces.
So no.
I have an actual question.
Okay, no. I want to answer this. This is very important to me. This is very important to me. So my dot files are on GitHub, all right? And you can see, oh my God, this is the worst. Oh, I should just turn on mirroring. I have lots of rules in my vimrc about spaces. I have auto commands for certain file types, but unless we're talking about make files, it's always spaces, always spaces. 4 for nearly everything, 2 for HTML and XML.
Okay, thank you. So my actual question was, the recommendation is that at some point you should use, Python or something that has data structures. How do you decide that point of transition? Like, should I write this in Bash or should I write this in a proper language?
I think if you're going over 100 lines, it should not be in Bash. Personally, about 3 years ago, I don't know, whenever I started using Reposado, saved my butt, I started teaching myself Python. And dirty little secret of this in the 25 minutes we have left that is burning into my soul right now, is that I haven't written a bash script in a long time. Quoting just erodes away at your soul. You can do it right, and you don't ever have problems. I don't have problems often. I still think in Bash. When I tackle a scripting problem, it's kind of weird. In my head, it's Bash first, and then I have to kind of translate it into Python. I guess I haven't been using it often enough for it to go that way. It's interesting. It's weird. But yeah, learning Python, given the number of tools, the open source tools available from the community here at PSU, is very helpful. But Bash is quick and easy. And there is I'm actually going to show you this one. Because this will illustrate why you might want to use Bash or Python and vice versa. I should really just search for my thing, because now this is going to, yep. Oh, this is the worst. I have I have a script. Here we go. Here are 2 scripts that do exactly the same thing. Can you guys even see that? Nope. Neither can I, so that's good. Now, there we go. 2 scripts that do exactly the same thing. I wrote them a while ago when I was kind of translating all my existing Bash scripts into Python. Here is how you set a monkey identifier to, well, using our naming convention. I set comp name to the computer name, and then I trim off the prefix of it. Our naming convention is 3 characters and then a dash, and then some other stuff. So I get the prefix, which is our department, and I want to set the client identifier for monkey to that prefix. So each at Glenbrook North, if you're in the English department, your client identifier is NENG, and that comes from your computer name. At Glenbrook South, if you're in the math department, it's SMTH. That is how you do it in Bash. 6 lines. Granted, I am using an external program, 2 external programs. Here is how you do it in Monkey. In Python. It's a lot more stuff. And it's dealing with all kinds of crazy foundation nonsense. I mean, granted, we're doing it directly. Obviously, defaults and SCUtil have tons of code of their own that this isn't addressing. But yeah, that's how you do the exact same thing in Python on OS 10. What else? 100 lines. If you go more than 100 lines, change to something else. And if you look at some of the setup scripts for Ubuntu and things like that, those are some of the worst. 300 lines is just terrible, terrible Bash. Some of the code is dead. It doesn't even run. It never will. It's the worst. I sound like I'm jaded. No, I love Bash. I love Bash. It's dear to my heart. What else? Ooh, that's a tough one. I think right now there's a lot of free and cool online tools, like How to Think Like a Computer Scientist or How to Think Like a Programmer. Learn Python the hard way is getting kind of, people don't want to recommend that too much anymore. In the Learn Python subreddit, they're not recommending that one so much anymore because he's really adamant about using Python 2, even though all of us in this room are kind of stuck on Python 2 because Apple, and other reasons, but mostly Apple. Same reason we're still kind of on Python or Bash 3. But yeah, How to Think Like a Computer Scientist is one. Udacity has two cool things. If you want a constant running program, they have a gaming one. And if you want just general Python computer science knowledge, there's another class for that as well, in that vein. And everybody else is really, really helpful in like the Python channel and the Mac admin Slack. Really nice folks. What else? Nothing? All right. Go forth, have 3 beers.